Sridhar Muppidi.
I think it's a great time to talk about data security and especially take a step back. Right? Personally, I've been spending more than 15 years in this area of data security, and I'm very privileged to meet and work with a large number of customers, hundreds of customers. Right? So what I thought I could do this morning is to take a step back, give you a little bit of a practitioner's approach on data security with a view to help you mature your own data security programs. Right? So I think just like most of you, I'm a technologist at heart, right? I've got most of my home, a smart home with more than 40 plus devices connected to the cloud. I don't worry about what they do, but they make my life very simple, very easy, right? Both my kids are in college, and I had to do a lease for both of them. 2 different apartments, 2 different states. You know the process is not easy, right? And I go to, with my travel, all I had to do is go to IBM and ask HR and then go spit out the appropriate employment letter, and it comes out in a minute or less, versus what we had to do in the past to go and schedule some time and call the HR and get something going, right? So I love what the innovation has helped us all. But at the same time, I'm a security guy. I understand the fact that, as you embrace cloud, you have data everywhere. As you embrace AI, the data that is trained to AI or the data that is being inferenced is all susceptible for risk. So as you look at these innovations, the attack surface itself is growing. It's growing not just in terms of the breadth of the attack surface, but also the depth, right? With the advancement of compute, with quantum, we are able to go and at least predict in the next decade or less than a decade, cryptography as we know would be broken, right? So these are the different risks that are in our way as we embrace some of the innovations. Not a bad thing, but we need to understand those and figure out a way to mitigate against that, right? So with the good, a little bit of bad, but it's okay to take the risk, right? Now, how do you get started? When you look at, data and AI and cloud and quantum, the first thing comes up is go protect the data. But I think it's good to understand that data now is not just, traditional data, structured data or databases, but also things like unstructured data, data which is in the cloud, data that is helping the AI models. I was actually reading up something the other day. The hottest in the market is Gen AI, of course. Nobody will dispute me on that. The second hottest thing is the litigations against Gen AI, right? So I think, but we got to think about how do you protect that, right? And typically we take a data-centric approach, which is depending upon what your data is and how you're accessing it, you want to be able to protect it. But the reality is with, more than 80 to 90% data generated in the last 2 to 3 years, and the explosion of endpoints, the combination of these things is astronomical, right? And it's huge. So how do you eat an elephant? Anybody? One bite at a time, right? So that's what we did. That's what I did to go and figure out, based on our conversations with clients, what is a structured way that we can go and take one bite out of this elephant with a maturity model, right? A maturity model, take it with a grain of salt, right? It works with many, many patterns. We're talking about hundreds of clients over here. Mileage varies depending upon your specific organization, and you may look at the slide and say, hey, my DLP is not in the right pocket, or my activity monitoring is in the right pocket. But if you look at the broad picture, what we're saying is you can't really protect what you don't see. You first have to understand where your data is, whether it's structured data, unstructured data, cloud data, managed data, unmanaged data, etc. Once you see that, then you have a mechanism to understand the risk, minimize the attack surface, and make some proactive mitigations. Then comes the question of, 2 things: compliance and protection with a view to do data leakage, as well as make sure that user has write access. In general, when a data is breached, it's about $4.8 million, a huge data breach. But when you have a compliance violation, a huge violation is usually double digit, right? So even though logically it makes sense to say, hey, let me go and see the data, protect the data, what I've seen customers do is go after compliance first, right? Show me how the data is being used. Then comes the question of, okay, let's just make sure that the data is protected and you detect anomalies and be able to go and support the security operations center. Now, we all know that we've been in technology, the attack surface will continue to grow, and that's what you see with the extend, right? That as the attack surface is growing, we need to embrace for these new innovations, not just AI and quantum or cloud, but supply chain or some of the new things, data in motion, data in use. These are some of the things that we'll see, right? So we have to embrace those and put those in a structured program like this. And then last not the least is, like I said, data security is not a new thing to most of you, but we've been working in silos, right? People are doing encryption, some people are doing key management, vulnerability management, data activity monitoring, DLP, and those are all good. But when you look at it in this lens of the explosion of data with the new technology, it's time to bring it together to a certain extent. Very similar to what we've done with Security Operations Center, right? Initially we said, you know what, it's okay to have it all in one place, but then we started thinking about EDR and CDR and et cetera, right? So that realization is also coming to say, we need to come together across these different programs so we can draw the insights from what we discovered so that we can do the right level of protection policies. So let's take a quick look in each one of these. And it's mid-morning, so I am going to interlude with a couple of videos as well, just to break it up. First and foremost is, like we said, right, you can't really secure what you don't know exists, right? And it's, this is not a new thing. People tend to think about structured data, but it's not just the structured data, right? It's unstructured data, semi-structured data, managed data, unmanaged data, in the cloud, on-prem. It's a hybrid world out there, right? And the idea is to continuously monitor it, not a one-time thing, but continuously monitor it. And typically we think about discovering data as a one-time thing or discovering data stores or data. But it's also the lineage or the movement. Data movement is also important, right? It's not enough to basically say this is high, medium, low, this is my crown jewels, but the fact that these crown jewels went to your Gmail account, from Gmail it went to a different account, that's important to find as well, right? Once you do that, you understand the attack surface. Now, the attack surface is huge, right? And then the next thing is finding the vulnerabilities in that attack surface, right? Which is misconfigurations. What are the databases that need to be patched? What is the data movement that shouldn't have happened has happened, right? Like going from one country to a different country, GDPR violation, right? Or some of the privacy issues, CCPA violations. So that's important to look at all the vulnerabilities and then take a mechanism to prioritize those. This is where AI is our friend, right? Where, and you'll see that throughout my discussion as well, that AI to me is like a power tool, right? It's not like replacing the humans per se, but 20 years ago, you used a manual, 30 years ago, you used manual, drill bit to drill a hole. But today, not having a drill bit is unconscionable, right? You cannot even think about going to your job without a drill bit or a power drill, right? So AI will become like that, and this is a use of AI to prioritize those vulnerabilities so that you have to focus on a few things that are meaningful versus fixing everything. We're actually working with a client a couple of years ago, few 100,000 vulnerabilities. Not a bad thing given the size of the organization, right? Because some are good, some are worrisome, some are not so worrisome. And we put AI model, which is a combination of business context, threat, vulnerability, and weaponization, that means how susceptible it is to attack that, we are able to reduce it to less than a few hundred that you can go and solve, basically. Now, data discovery and classification has been a relatively manual process for many years, right? A lot of consulting activity which has gone on to do that. But as you look at the new world, technology has evolved. If you roll the video really quick, technology has evolved regardless of what product it is. The fact is, you're basically connecting to places where the data is, whether it's a cloud provider, whether it's a SaaS applications. In IBM, we have 800 SaaS applications, right? You connect to those, you provide the credentials, right? Behind the scenes, you going and configuring a set of things like creating a service account, creating the appropriate processes, making sure that you're continuously scanning for the environment versus manually discovering that. At the result of that, you get an inventory of all the data, structured, semi-structured, et cetera, in a graph manner, because the relationship is also important. This is where NLP, or natural language processing, can come into play to say, how do I go and classify certain documents to be highly sensitive, crown jewels, or not crown jewels, right? This is, again, a power tool to leverage. That gives you the visibility, right? Now, the next thing is vulnerabilities. How do you go and look at the vulnerabilities? Not just the database vulnerabilities of patch management, operating systems, being able to go and look at this specific activity, but also the movement of data, right? And once you understand the vulnerabilities, then comes a question of being able to use AI to be able to prioritize that and mitigate that, mostly automatically, but even if you do it with some level of integration with service management, or that helps in being more proactive and reducing the attack surface. So what's step number one, right? Step number two is okay, now, like I said, these are not necessarily sequential steps. Could be run in parallel. I'm sure you understand that too. But in the interest of what I have seen from customers, compliance comes up quite a number of times ahead, right? This is able to explaining the data of who has access to what and what they have done with it, whether it's regular user, privileged user, be able to look at and be able to demonstrate compliance, whether it's your PCI, whether it's HIPAA, whether it's SOX compliance or CCPA. Those are just examples, basically. Now, this is again not a new thing, right? The challenge over here is we see a lot of clients spend enormous amount of time running after audits and demonstrating compliance, right? This day and age, unfortunately, I still see that, right? And I think we got to basically evolve how compliance is done. It starts with regulatory requirements, for sure, right? Whatever the regulatory requirement, and there's technology right now to basically take a regulatory requirement, use an LP to spit out whether it's requirements, whether it's goals, whether it's controls, depending upon what you need to show. And those goals or requirements or controls need to be deployed within your environment. Enable activity monitoring or enable encryption. These are examples of that. And then you continuously monitor, whether it's agent-based or agentless. That's just a religious war, basically, in terms of how much granularity you get. Depending upon your mileage, that may be one versus the other or both. Once you do that, that's when you're able to go and not only demonstrate compliance automatically and continuously, but be able to detect the drift. Hey, this control was there, but my friend over here has changed that to allow Sridhar access to this database, right? That's a drift. So how do you go and detect those drifts and mitigate them? So that notion of continuous compliance helps in not running after audits, but being able to have a continuous state of compliance and only be alerted when there are a potential issues, right? So in general, a few years ago I learned this, right? I mean, and just drawing it, I digress, but I wanted to for a second. Authentication systems, right? Most of us are good people, but the systems these days are designed for the one person that don't necessarily put the secure password or the strong password. As a result, everybody's being punished for that with a, frictionful experience, right? Instead, I think what we are talking about over here is designing the system to be frictionless for the 90+% and flagging when there's an issue, basically. Now, protection, like I said, it could have been started before, it could have been started later, is a broad topic. It's about, like I said, enabling the right identity. I chose the word identity because it's not just a user, it could be human or not human, right? Having access to the right data under the right conditions for the right purpose. The purpose is for privacy reasons, right? Easier said than done, that mouthful. Now, that usually has context-based access, et cetera, which I think is not a new topic, but applied to a large amount of data right now. But in addition to that, protection could be things like encryption, right? Encryption of data at rest, data in motion, which mostly is TLS, SSL, and things like that. But data in use is getting a lot of traction as well, especially if you have things like highly sensitive data transactions that you don't want to go and process this in a third party. Using something like confidential computing is another way of doing that, basically, right? Homomorphic encryption also kind of falls into that space where you're encrypting the data, putting it in the cloud, and doing analytics on top of it. So I'm using the word encryption, obfuscation, redaction, all of that, like loosely in that area, basically, right? Now, just like good citizens of following the zero trust principles, you just have to continuously monitor, right? That doesn't go away. As you monitor, this is where you can go and look for anomalies not just in activity, but also behavior, right? That becomes important. And then you can take, whether it's a mitigation step proactively, whether it's a remediation step to basically say, hey, I want to mask it, I want to redact it before the data goes to cloud. That becomes a policy, basically. Now, the thing that we observed over here fairly consistently across our customers is that most customers do some level of auditing and activity monitoring. But then they take their whole thing and send it to the SOC, right? The problem with that is there's no context, and then you end up sending a lot of noise. As a result, the important signals get lost in the noise. Unfortunately, I work with a situation, large customer, they actually found out that there was a bad privileged activity going on the night before. They alerted the SOC, but it was so buried in so much of other data that it just got lost, that unfortunately this specific organization got hit with I believe a few million passwords were stolen, basically, right? Not a great example, but I say that because, if you don't make the signals meaningful, they'll get lost, right? This is again, where AI is a good help for us, right? And there's maturity in there, right? There's two aspects of AI over here. One is to be able to go and look at all the data and improve the accuracy of a potential risky behavior. And then the second one is to basically now accelerate the investigation to be able to go and make sure that this needs to be sent for further investigation, right? So let's take a quick look. If you could roll the video, please. So here what you're seeing is, regardless, I'm just using these examples, right? AI is used to go find that this is a SQL injection. Usually, something like that, it takes an analyst about 20 to 25 minutes, a really good analyst, to look at the context of, is this really a SQL injection, right? From vulnerabilities, from threat context, from the business context, from the weaponization context, and then come back and say, this could be a potential issue. This is where Gen AI could be helpful. Even though it's in infancy, it's okay to take that because now you're basically summarizing the information of what you have. Of course, you can put the guardrails around how much data is leaving the organization. Be able to summarize the incident, be able to ask questions, and get to the root cause of the situation really quickly. You're accelerating the investigation time exponentially, right? And you're improving the accuracy of detection. You can go back and double check, with Gen AI-based policy generation to say, okay, tell me more, and until you're satisfied before you take the action to go send it over to the SOC. I show this because this is where, the state of the technologies today, right? So if you go to the next slide, okay, one too quick. So we talked about getting a full visibility. We talked about being able to go and put the right appropriate policy for demonstrate compliance as well as protection. We talk about the use of power tools to be able to go and use the time wisely, right? But the attack surface continues to grow, like we said, right? The explosion of AI is going to continue to grow, in the next few years for sure, right? We're just in the infancy. We're just starting, right? As well as we're hitting as much as we see the adoption of cloud. There's still a lot of projects haven't embraced cloud as much as we think they have, right? So we'll continue to see a growth in that, as well as we have the advancements of compute in the next 10 years or even before the next 10 years. So let's take a quick look at a couple of these things just to see how to think about it, right? Now, if I look at AI, why am I showing this, right? If I look at pipeline of AI, usually it involves some level of data collection, which tunes a model, right? And the model is then served to an application. Attacks can happen at the data level, which is poisoning the data or wrong access control. Attacks can happen at the model level, right? Supply chain issues, et cetera. Attacks can happen at the inferencing level, where you can do things like jailbreaking and prompt injection attacks. And even, anybody played 20 questions with kids? It's exactly like that, right? Like, yes, no answer. You can keep asking the question until the model is going to basically give you all the answers and you can reconstruct everything you want, right? So that's data, right? So data is hit at all different phases, basically. To protect it, listen, this is not the focus of my discussion, but I did leave some links for those of you interested with the framework and approach over there. But the idea of this is to show that we need to take a structured approach of securing the infrastructure. You cannot forget hygiene, right? People tend to run to the next technology, but you cannot forget hygiene, like brushing the teeth when you have COVID, right? You still have to do that. At the same time, you have the heightened need to go not touch the face or put a mask, et cetera. Those are additional controls. So that's what you see over here, right? Governance and securing the infrastructure, that's hygiene. In addition, there's specific controls for securing the data, application, and models. I say that because this is relevant in the data discussion as well. The interaction of these things become really important. For example, most of you are familiar with RAG pattern, like a chatbot, right? So let's take an example, right? So I have access to an application which has the data behind it, and probably Joe in the audience has access to it, but does not have access to that. But then if that information is vectorized and go into a vector store, when a chat application is calling that, it doesn't differentiate and propagate the access control from the main database itself. So we're beginning to see some of those issues surface up. And that's the reason why we need to look at not just the data, but where the data is used and how it's being used. So if you roll the video again really quickly, right, it's the same principle of being able to go and look at an environment, whether it is an OpenAI, whether it's Azure, whether it's IBM, it doesn't really matter, right? But the idea is that once you go and start scanning the environment, This time around, you want to be able to go and look at the inventory of not only your data, but also applications and models and how they are interacting with each other. And that becomes really important to understand if the data is being used for training, for tuning, for RAG inferencing, for vector store, whatever that is, so that we can apply the right sort of policies and protection, right? It's also important to look at the vulnerabilities associated with each one of these, very similar to what we've done before, right? To make sure that, not just the model security, but also the data security principles are applied over here. So just a quick snippet to show how to think about this. Now, the next innovation I want to quickly talk about is quantum, right? In quantum, we know that there's both of you don't know the potential threat of quantum where the compute power is going to increase so much that it's going to break cryptography as we know today. Cryptography, its public key is going to be broken, symmetric key is halved, right? That's a thesis over here, and it's proved by a couple of algorithms, right? And most of, being at IBM, I can see the progression of the compute in quantum. I've seen more than what I expected in the last 5-6 years, right? Right now, we're dealing with almost 1,000 qubits, and it's not just one computer, but able to connect to different computers, basically, right? So the threat of, potential break is real within the next 10 years or less, right? That's what a lot of predictions say, right? Why do we care about it? We care about it for a couple of reasons, right? One is the simple reason of attackers are harvesting right now, they'll decrypt later. Not because they want your email address and thing. They want to understand the transaction behavior behind how you do business, basically. That's where the money is, right? Second reason you want to care about is the fact that time value of money, or time value of data, right? The time value of data for a car is 30 years. That means a decision that they make to put crypto in a car, they have to live it for 30 years. If something changes, you have to recall all the cars, and you guys know how expensive that could be, right? Passport, US passport is 10 years, right? Some of the medical records are 7 years. So the decisions that you're making right now may cut through the time that cryptography may be broken. So might as well start thinking about a new type of cryptography right now, right? So how do you go about that? It's a similar philosophy of, in the interest of time, I'm not rolling another video, but the idea is to go and look at the entire cryptographic inventory from applications to network to servers to users, secrets and keys, so that you're now able to go and map that to compliance, as well as the risk associated with that, so you can prioritize how do you want to go address that in a structured manner, right? Now, this general perception is that quantum is a one-time thing, and there's analogies made to Y2K, right? YQK is what is coming. It's actually incorrect, right? It's more of a continuous thing where it's an opportunity for us to step back and do cryptography right? What we call crypto agility, which is opportunity to go, when was the last time we did a complete inventory of cryptography in our organizations? Never, right? So opportunity to bring all of that together, put some risk analysis on top of it, so that we can then go and provide the appropriate mitigation techniques. So let me end with a quick comment, right? So the last phase of the maturity model. Everything I talked about happens to a certain extent, but it happens in pockets. And that's not a bad thing for where we are in the market. But as we move to this exponential growth of data, right, exponential acceleration of technology, I think it's time to kind of step back to draw insights from adjacencies, like understand the context of data to basically define what's the level of crypto I need to put in there. Be able to go and say that, hey, the activity monitoring on one domain map to an activity monitoring different domain helps in terms of mitigating the risk. Or the data lineage between one application, different applications, help do data leakage prevention. That becomes important, and this is where some of the terminology around DSP is evolving, I'm not too worried about the market over there as long as we focus on the open aspect of it. I was actually doing a lot of research on that, and I found the SANS Institute. As humans, as cyber defenders, we don't tend to work with each other as much as the attackers are working with each other, right? And it costs a lot of money to make these integrations. Hence, embracing a little bit of an open approach over here in terms of an open platform helps in terms of accelerating your maturity of your data security program. So with that, I want to thank you. Again, it's not a brand new topic per se, but I want to take a structured approach of how you can potentially mature your own data security program within your organization. Thank you, everybody.